Hey, good morning, class. I'm sorry there's been a small change in plans today. Instead of doing the live lesson, you are going to be watching this video. There will be times where you're going to want to pause this so that you can work a problem or two and then resume so that you can see your answers. I'm going to work through this. I'll tell you when you should be pausing it and when you should be just taking notes. So right now, if you have not completed the warm-up, please pause this and complete the warm-up. Then come back to this to see the answer to the warm-up. Please pause now. So your solution to this problem would be, 1 minute. Since x has a power of 5 in the numerator and a power of 2 in the denominator, that would be x to the 5 minus 2. The x minus 3 has an exponent of 2 in the numerator, exponent of 3 in the denominator. This is just one way to look at it. I'm trying to give you a little something different. That would be x minus 3 to the 2 minus 3. Well, 5 minus 2 is x to the third, and that would be x minus 3 to the negative 1. So instead of writing it as a negative 1, we're going to write it as x minus 3 to a positive 1 in the denominator, or x cubed over x minus 3. Now x cannot be 0. That's from the first statement. We have to always start, when you're doing this, this check on what x cannot equal, it always comes from what you start with. So x cannot be 0, and x cannot be 3. Please advance to the next slide. Today's lesson is about simplifying rational expressions and operations on rational expressions. So let's take a look at part A, B, and B. In part A, we have this rational expression, which is, let me find a highlighter, x squared plus 4x plus 3. That's a polynomial. So the rational expression overall is x squared plus 4x plus 3 over 4x plus 3. We have a polynomial in the numerator of x squared plus 4x plus 3, and then also a polynomial in the denominator of 4x plus 3. Sometimes students look at this and say, well, I can reduce these terms of the polynomial, as I did with the red. They take the 4x, which is a term in the numerator, and they cancel it with the 4x term in the denominator. And then they do the same thing with the 3. You cannot do this. Terms cannot be canceled. What you can do is you can take that numerator and factor it so that you have x plus 2 times 4x plus 3 over 4x plus 3. And now factors can reduce. The 4x plus 3 and the 4x plus 3 cancel. You can do this. Factors can be canceled. Now, also note in these statements, it says what x cannot equal, because in the beginning, we had this 4x plus 3 in the denominator, and you can never have 0 in the denominator. So the 4x plus 3 cannot equal 0, and now just get x by itself. Subtract 3, divide by 4, and x cannot equal a negative 3/4. Please advance to the next slide. So that was reducing rational expression. Now let's apply some of that to more complex rational expressions. I'm going to do 2 of these, and then I will have you do 1 of them. So I'm going to do 1 and 3. In problem 1, we have a 2x minus 7 to the 6th power over 2x minus 7 to the 2nd power times x plus 1. Well, I can reduce these factors. 2x minus 7 is a factor in the numerator, and 2x minus 7 is a factor in the denominator. So if I take and subtract my exponents, in part 1, I get a 2x minus 7 in the numerator to the 4th power over x plus 1, where x cannot equal a -1, or take that 2x minus 7, set that equal to 0, add 7 to both sides, divide by 2. Oops, 2x minus 7 cannot equal 0, and so x cannot equal 7/2. Now in part 3, I'm going to try to simplify this. I'm looking at this 5x plus 3, or 5x minus 3 in the denominator, and it kind of looks like what's in the numerator, but it's not quite the same. So I'm going to take that numerator, and I'm going to factor out a -1 from each term. So if I remove a -1, that leaves me with a -3 plus 5x. Well, that's just like what I have in the denominator, just in reverse order. So I can reduce those 2 factors, and that gives me a -1 in the numerator over 3x plus 1 in the denominator. But now x cannot equal, let's take both of those. See, 5x minus 3 cannot be 0. Add 3 to both sides. Divide by 5. So x cannot be 3/5. And let's take 3x plus 1 and do the same thing. 3x plus 1 cannot equal 0. Subtract 1 from both sides. Divide by 3. X cannot equal a -1/3. Now I'm going to have you do part 2, but first I'm going to give you a hint. Factor the numerator and factor the denominator. So please pause this now and then return in a minute, or when you get the problem done. All right, welcome back. Now, if you're going to factor your numerator, you're going to use your squares and diamonds. Something has to add up to a -11x, but multiply to a -12x squared. Well, that's going to be a -12x and a +1x. So I'm going to take and put a 4x squared in this box and a -3 down here, a -12x and 1x. This to me looks like 4x. This will be x, and over here 1, and a -3 down here. So the numerator factors into 4x plus 1 times x minus 3. The denominator, some of you comment that all you need to do is really use your diamonds. If the coefficient of x squared is 1, you can get by with using just the diamond part of diamonds and squares. It has to multiply to a -6x squared, but add to a -x. That would be a -3x and a -2x. I'm going to take it all the way through so that you can see why you'd only need the diamond portion. So x squared, -6, -3x, -2x, x times x. This has to be a -3, this has to be a -2. So we get x minus 3 times x plus 2. So right here, that -3 and that -2 is why you can just get by with only using the diamond portion. You really don't need the square. So now let's finish this off. The x minus 3's cancel. And I get 4x plus 1 over x plus 2. But remember, we gotta talk about what x cannot equal, where x cannot equal 3 or a -2. Please advance to the next slide. Now we're going to move from simplifying rational expressions into multiplying and dividing rational expressions. So this is now multiply or divide rational expressions. The first thing to remember when multiplying or dividing rational expressions is you want your rational expression in factored form. So I'm going to write this as 12 times x plus 9 to the 4th power over 8 times x times, my numerator factors into x times x plus 5. That's removing the greatest common factor. And then x plus 9 to the 12th power. When I multiply all this together, what I get is 12 times x, remember multiplication order doesn't matter, times x plus 9 to the 4th power times x plus 5, all over 8 times x plus 9 to the 12th power. Well, my x's cancel, I can easily see that. The x plus 9 to the 4th power and x plus 9 to the 12th power, well, that would be subtracting your exponents. So I'm just going to do that on the side. That's going to be x plus 9 to the 4 minus 12, which would be x plus 9 to the -8, which really means I have x plus 9 in the denominator. So what I have so far is my x plus 9 to the 8th power, the x plus 5. It doesn't cancel, but I still need to deal with this 12 over 8. Well, 4 goes into 8 2 times. 4 goes into 12 3 times. So that leaves me with the 3 in the numerator and the 2 in the denominator, and x cannot equal, go back to the original problem, 0 or a -9. So that's multiplying rational expressions. Go on to the next slide. But what about dividing rational expressions? Well, start out with the same process. First thing you want to do is write it in factored form. Then you want to change division into multiplication. So let's take and factor our numerator. I'm going to use squares and diamonds. Has to add to a negative 14x, but multiply to a negative 15x squared. That's going to be a negative 15x. See if I can squeeze it in here. Negative 15x and a 1x. So I have 5x squared, negative 3, negative 15x, and 1x. Well, this is going to be 5x times x. This is going to be 1. This is going to be a negative 3. So that's what my numerator of the first rational expression factors into. The denominator of the first rational expression, this is the difference of two perfect squares. So that's going to factor into x minus 3 times x minus 3. So my first fraction is 5x minus 1 times x minus 3 over x minus 3 times x minus 3. Oops, division. Divided by. Now factor both your numerator and denominator. Okay, so I paused it and did all the squares and diamonds work on the left. If you want to pause this and take a look at that before we proceed. But the second rational expression in factored form looks like this. Now, change division into multiplication. So I'm going to multiply by the reciprocal of the second rational expression. So this is going to look like 5x minus 1 times x minus 3 over x minus 3 times x minus 3 times, now flip this around, 2x minus 1 times x plus 1, 5x plus 1 times x plus 1. Then the third step is to reduce factors. Now, some students always seem to believe it's a little easier if we write this all as one big fraction. So 5x minus 1 times x minus 3 times 2x minus 1 times x plus 1 all over x minus 3 times x minus 3 times 5x plus 1 times x plus 1. That helps see what we can reduce. Well, those reduce, and that is it. Now this is a positive 1, and that's a minus 1, so they're not going to reduce. Oops, I got a mistake back there. Hang on. So let me slide this over. This was 5x plus 1, and I wrote a minus 1 over there. I thought those were supposed to reduce. And so I'm going to change that throughout the problem And now those also reduce. And that leaves us with 2x minus 1 over x minus 3, where x cannot equal, let's go back to what we have up here, 3 and a negative 1/5 and a negative 1. Oops, sorry for moving that on you. Remember, you can always pause this if I'm writing too fast, which probably happens. Now let's take a look at part C, just to change colors so that we can keep them separate. This is multiplication, so let's just write it in factored form. I'm going to start by taking this first fraction and removing a greatest common factor, x times x squared minus 16 over x to the 6th times. I'm noticing that 3 minus 2x just kind of looks a little weird because we usually write it with an x being the first term. So I'm going to factor out a negative 1, and that's going to leave me with a positive 2x minus 3. And then in the denominator, use your squares and diamonds. And again, I'm going to pause this and do that real quick for you. So that factors into 2x minus 3 times x plus 4. So overall, if I want to write this as one big fraction, I have x, oh, but look at that. X squared minus 16 is x minus 4 times x plus 4 times a negative 1 times 2x minus 3 all over x to the 6th times 2x minus 3 times x plus 4. And that simplifies those cross reduce to an x to the 5th in the denominator. The 2x minus 3's cancel, the x plus 4's cancel, and so I have a negative 1 times x minus 4 over x to the 5th, where x cannot equal. Go back to the original problem, right there, or right here. X cannot be 0. That comes from that statement. And then from over here, x cannot be 3/2 or a negative 4. Advance to the next slide. So that was examples of multiplying and dividing rational expressions. Now we're going to get into adding and subtracting rational expressions. Is 3x over 2x plus 5 plus 12 over 2x plus 5 equivalent to 3x plus 12 over 4x plus 10? The answer is no. When adding or subtracting, rational expressions, you add or subtract. I'll write that out. numerator when you have a common denominator. So 3x over 2x plus 5 plus 12 over 2x plus 5 equals, add your numerators and keep the common denominator. Each fraction has the same denominator, or each rational expression. Advance to the next slide. So in order to determine a common denominator, we're going to use that concept of a giant 1. So if we take the example that they have on this page, I'm going to take 3x over x plus 1, and I want to add 7 over x plus 1 times x minus 6. Well, I don't have a common denominator, so I'm going to multiply by a giant 1 so that each rational expression has the same denominator. The one on the right has an x plus 1 factor and an x minus 6 factor. The rational expression on the left only has the x plus 1 factor. So I need to multiply by a giant 1 of x minus 6 over x minus 6. That gives me 3x times x minus 6 over x minus 6 times x plus 1 plus 7 over x plus 1 times x minus 6. Add your numerators together. So that's 3x times x minus 6 plus 7 over x plus 1 times x minus 6. Now let's clean that numerator up by distributing and then adding 7. So that's going to give me 3x squared minus 18x plus 7 over x plus 1 times x minus 6. Now, the steps involved in this, number 1 is to get a common denominator. Step 2, I should clarify that or specify. Get a common denominator by multiplying by a giant 1. Step 2, add or subtract your numerators, keeping the common denominator. Three, and this is going to come up in a later problem. See if the numerator is factorable and if you can reduce the expression. Step 4, what can x not equal? So here was step 1. Here was step 2. Step 3, this numerator it's not factorable. And now step 4, go back to the original expression. X cannot equal a -1, or x cannot equal 6. Advance to the next screen. So I'm going to do one of these and have you do one. I'm going to start by doing the second one. And I'm going to pause this and do all the factoring. And then it'll just pop up on your screen. Okay, welcome back. The numerator in part B is not factorable. The denominator is the difference of two perfect squares, so that factors into 4x minus 1 times 4x plus 1. I need to now get a giant 1. So the second rational expression does not have a 4x plus 1 in it. So I'm going to multiply by 4x plus 1 over 4x plus 1. And what that gives me now is 4x squared plus 5x minus 5 over 4x minus 1 times 4x plus 1 minus, and I'm going to expand this while I'm rewriting this. So it's going to be 4x squared minus 7x minus 2 over 4x minus 1 times 4x plus 1. Now that you have common denominators, subtract this. And one of the key things to remember is it's going to be minus all of that in the numerator. So my overall numerator now has, I'm going to write all of this down, 4x squared plus 5x minus 5 minus a 4x squared. And then that's minus a minus, so that's going to be plus 7x. And then minus a minus, that is going to be plus 2. All over 4x minus 1 times 4x plus 1. Cleaning that up, in my numerator, I have a 4x squared minus a 4x squared. That gives me 0. 5x plus 7x. So those add to 0. 5x plus 7x is 12x minus 5 plus 2 is minus 3 over 4x minus 1 times 4x plus 1. But I'm noticing in my numerator, give me a little more room here, hang on. Oops. I'm noticing in the numerator that I can factor a 3 out. If I remove a 3, then that leaves me with 4x minus 1 over 4x minus 1 times 4x plus 1. And I can reduce this. The 4x minus 1's cancel. And I'm left with 3 over 4x plus 1, where x cannot equal, well, if I go back to my original problem and take a look at everything in the numerator, oops, x cannot equal 1/4 or a negative 1/4. What I would like you to do is try part A. I'm going to give you a hint. 4 is the same as 4 over 1. Get a common denominator and then subtract your fractions. Please pause this now. Okay, welcome back. I just rewrote the problem, and then I multiplied by the giant 1 right here. And in the process of multiplying by a giant 1, I got my common denominator and then distributed that 4. And remember, this is minus everything. So that became minus a 4x and minus a 12. So my numerator of my rational expression is going to be 5x minus 4x minus 12. The denominator, x plus 3. Combine your like terms, and you get x minus 12 over x plus 3, where x cannot equal a negative 3. Advance to the next slide. If you want to do these, that's fine. I'm going to, or if you want to do these, then you know what you're going to want to do is pause this in just a minute and do the work, and then come back and take a look at the answers. In order to get this uploaded in a short enough file so that it's not too long for you, I've got to not work through all of these problems. There are also 2 additional videos. They are on the page for today, or the Canvas page for today, at the bottom. They're underneath that supplemental section. One of them deals with adding rational expressions. The other one deals with subtracting rational expressions. So I'm going to work these problems now. So please pause this if you want to work them now. Okay, welcome back. You can take a look at part C. Your common denominator happens to be 12x to the 4th, so you had to multiply by giant 1s to create that in the denominator of each of those rational expressions. Part D, when you factor the denominators in the first rational expression, your denominator is 2x plus 5 times x minus 1. In the second rational expression, you get 2x plus 5 times x minus 3. Notice how these reduce. Then, after those reduce, we have this expression of 3x over 2x plus 5 times x minus 1 minus 2 over 2x plus 5. Your giant 1 is going to be x minus 1 over x minus 1. Forgot the little fraction bar there. And then simplify, clean things up a little bit. Now, in our denominator, 2x plus 5, well, that means x cannot be a negative 5 halves. X cannot be 1, but you always want to look back to the original expression. And there was that x minus 3, so that has to be part of your statement of what x cannot equal. So hopefully this lesson is going to work for you. Please bring your questions to class on Tuesday, and I'll do my best to answer them then. Have yourself a great day.